20, a young graduate of the Clifton, New Jersey High School arrived at Princeton. Hubert Alyea was an enthusiastic student with a special love for chemistry. Despite a year's interruption to recover from an attack of polio, he was elected to Phi Beta Kappa in his junior year and graduated with highest honors in 1925. Later, he received his Ph.D. from Princeton and became a member of the faculty in 1930. An eminent chemist, Professor Alyea taught at the university for 42 years. But his classroom was never confined to the campus. Through television and as a guest lecturer, he infected millions of people around the world with his enthusiasm and love for science. His lectures and demonstrations are legendary, and during reunions each year, he repeats the final lecture from Chemistry 104, which always brought his students to their feet. Here are excerpts from that lecture taped at Louisiana State University.
I got this chemistry, all kinds of fantastic, they don't want to know about all kinds of fantastic things happen in chemistry. That's magic. Oh, that's magic. But you know, that isn't nearly as exciting as happened to this paper. Turned to black carbon, invisible carbon dioxide, water coming out. That's magic. But this is chemistry. And the fantastic things that happen in chemistry. It's amazing how many things in chemistry were discovered completely by accident. But not only in chemistry. After all, Columbus set out to discover a way to the Indies and discovered our continent. The Bayer company that make the aspirin, they had spent 28 million marks, $7 million, trying to make a substance called orthophthalic acid, from which they make dyes and drugs and plastics and so on. And after 4 years of failure, one day a clumsy laboratory boy did something we tell them never to do in a chem lab. He stirred that stuff with a thermometer. The thing just turned into the desired orthophthalic acid because the mercury thermometer broke, and mercury was the catalyst. And from that minute on, the Bayer company used the mercury catalyst process for making their dyes and their drugs. They made $3 million profit a year with the mercury catalyst process, and they raised the kid's salary $1 a week. An apple dropped off a tree on Sir Isaac Newton's head. Now, this happened to many before, but it remained for the prepared mind of Sir Isaac Newton to read into the motion of the apple toward his head the forces of gravity and the motion of the planets around the sun. Again and again, we're going to see, as Pasteur so aptly said, chance favors only the prepared mind. And I'm going to show you lucky accidents in the field of plastics and in biochemistry and in energy, where lucky accidents were responsible for all kinds of fantastic innovation. I want to show you what we do when we have a heavy snowstorm in Princeton. We are lazy. We don't bother to shovel up the snow. We burn it up, you see. And of course, if you get tired and you don't want to burn it up, well, then you can pick it up, you see. Let's have the lights on all that, because I don't want you to be afraid. We're not in any danger at all. The second lucky accident happened over in New York. John Wesley Hyatt, Prince's devil, was trying to make a synthetic billiard ball. You see, elephants were just big enough to make ivory billiard balls out of it, getting scarcer and scarcer in the African jungles. And since you couldn't breed elephants as fast as the Belgian hares, they all never tried anybody to make a synthetic billiard ball. They tried to make them. He made compressed wood, incidentally, John Wesley Hyatt. But one day he cut his finger. He went to the same for this new skin. It was oozing out. And it looked sticky. He said, why can't I take the ground up ivory from the tusk of baby elephant, then off of those, and cement it together? It worked fine. Because you see, what he had done, he had discovered Duco cement before the DuPont company had. It worked fine. There was only one trouble. I'll turn the light on again because I want to share what happened. There's only one trouble. When they began to nitrate these things, sometimes they didn't know quite how to nitrate, and they over-nitrated, and they kept cellulose trinitrate, and that was gun cotton, and the billiard balls were explosive. But because he was working with us, John Wesley Hyatt, one day mixed that cellulose trinitrate with just ordinary household camphor. And a fabulous new product was discovered, celluloid, the first of our plastic. It's very exciting, folks. Let's see if you can turn that off now. It's very exciting that the age of plastic began here in the United States. You had 300 years of alchemy in Europe. But the age of plastic, there are 120,000 members of the American Chemical Society. 60% of them do something connected with plastics. And that age of plastics, born here in the United States, because John Wesley hired it, cut his finger, and mixed that as a new skin with the celluloid. Fabulous beginning, a lucky accident, began a fabulous era. Now the next era, home, it tells about petroleum. I'm going to talk about that one. You know, carbon has 4 bonds about it. And these people who know about organic chemistry and so on will show you that carbon has 1, 2, 3, 1, 4. 1, 2, 3, 4. And it has a hydrogen and 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 a hydrogen. There's only one trouble. We know a compound that has this formula. And people are sort of worried about that because it only has 3 bonds around it. And then a very clever chemist said, there's a thing called a double bond. They put in a double bond like that. Carbon's sort of stupid and think it has 4 bonds around. But double bond is very, very reactive. It's unsaturated for you ladies. The food that's the unsaturates are the ones that have the double bond in them. And they are very reactive. It's like a sailor standing in the street corner. There's a double bond. And what happens when a couple of pretty girls go by? I'm going to show you this because I'm going to give you the background of a chemical that was discovered by the DuPont company. It has turned out to the tune of over 100,000 pounds a year of plastic, and it was discovered completely by accident. I'm going to do an experiment to show this first. I'm going to take some bromine, and I'm going to take some, I invented this experiment, so I'm very proud of it. I'm going to take some bacon, and I'm going to cook the bacon the way my wife does. I'm going to burn it. And now, when I take it and I heat this bacon, it'll begin to drip. If you are a chemist, it forms acroleum. It forms an unsaturated compound. And it'll begin to drip. Then I'm going to drop it into there, and the double bond will open up, and the bromine will add on to it, and it'll form a colorless. It'll take about a minute for it to happen. It won't happen instantly, but you'll see a great difference between these are the same color at the minute. It's dropping nicely now. Drop this in here. I'll probably have to shake it a minute with you. And the bromine gas will go down and add on to that double bond, just as I had shown there. And when I shake it, you'll see it begin to get color. Oh, it's a beautiful experiment. You show your, you do it with petroleum. If you take petroleum, drop it on hot steel wool. You crack the petroleum the same way you get the double bond. And you can see it's getting fainter. And in about 2 minutes, this will be absolutely colorless as the bromine has added on to the double bond. And there we have a most unusual compound, bacon dibromide. And that's the story of Teflon. It happened at DuPont Company right before the war. They were working with these fluorinated hydrocarbons. I'm not going to squirt this out, be afraid. They were working with these hydrocarbons because the fluorinated hydrocarbons remain liquid at any temperature. So they use them in fuel lines. Over in Africa, a plane might be on the desert at 115 degrees, and 10 minutes later, up in the stratosphere at 90-60 degrees. And if they have oil, the oil would solidify. But the tetrafluoroethylene thing didn't. And so they're working with these. And one day, Roy Plunkett, a young fellow just out of you can turn that off now if you want. Roy Plunkett, just a young fellow, 2 years out of his PhD with Ohio State, had been working all day with this. An assistant came to him in 1939. This is the discovery of Teflon. And he said, Doc, something very strange happened. He said, I filled this, I weighed the tank empty this morning. I filled it with, so I filled it with tetrafluoroethylene gas. I use it all day. It's empty tonight, Doc. But you know, Doc, it's heavier tonight empty than it was empty this morning. Well, of course, Roy said the first thing I thought was that he made it wrong weighing, but he's a very careful fellow. And I said, well, I guess the gas is in there. The valve's just stuck. So he said, we took this off and no gas came out. Then we got a Stilton wrench, we took this off and no gas came out. Now, not on the prepared mind, because I'm talking about the prepared mind that he discovered. Roy Plunkett would have said to us, look, if you don't weigh carefully, we're going to fire you. And he'd thrown it away. But he thought maybe the gas is solidifying in there. just like those liquids solidified there. Maybe the gas is solidified in there. And he took a wire and he stuck it down inside that tank, and he drew out of the tanker some of this white, waxy Teflon, the first ever seen by man. He said, we weren't very excited about it because we get gunks like this in the organic chemistry all the time. And it was near closing time too. But he said, I thought I'd do a last experiment before I went home. So I took that Teflon and I sliced it up and I boiled it in water, nothing. I boiled it sulfuric acid, concentrated sulfuric acid, boiled it sodium hydroxide, boiled it benzene, boiled it methyl ethyl ketone, nothing happened. Then I got interested in it. Then I began to heat it. Now all these vinyl compounds all go to pieces around 150 to 160 centigrade. Roy said I heated that in 1939. I heated to 100, 150, 200, 250, 300, 350, 400. Boy, we knew there in DuPont we had a fantastic plastic. We patented it right away. We told the customers about it. He says, you know, Doc, I think it was packed full of this way. He said, you know, Doc, the next week I got 300 letters from customers asking for samples. And then, by golly, the DuPont company didn't know how to make it. It took them 5 years to discover silver as the catalyst. And to this day, they don't know. I saw a letter he wrote to a friend about 3 years ago in Detroit. He says, 2 lucky accidents happened that day they gave us Teflon. First, silver is the catalyst. And accidentally, they must have used a silver gasket in that tank that day. And secondly, the very critical exact amount, 0.0001% of oxygen must be mixed with the tetrafluoroethylene for it to go and not explode. We do it carefully. And it did, and it's Teflon I given because the accidental discovery and the prepared mind of Roy Plunkett to make that discovery. We've all seen a fusion reaction up there in the sun. That's what keeps the sun out. Every second of your life, 600 million tons of deuterium are reacting to keep the sun out. And we're trying to duplicate that on Earth. Well, now let me quickly show you something. They're almost done now. Some experiments, chemical experiments. Well, when we burned, at the very beginning, you know, when we burned that paper, it was a chemical reaction. The carbon, hydrogen, and oxygen of the paper began to burn from carbon dioxide. When you burn that wood, because after all the paper is made from carbon dioxide and water, if I take this piece of paper, a piece of sugar, and I burn it, I'll get down inside of me. Tomorrow when I want to beat my wife, I need some energy. Where will I get it? I'll breathe in oxygen. It'll burn up the sugar. I'll breathe out carbon dioxide, perspire water, and instead of giving me heat and flame, you give muscular energy and poor wife. Well, those are all chemical reactions. Here's another chemical reaction. A pop bottle with hydrogen oxygen in it. It's a marriage of hydrogen to form water. Da, 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 da. In case the ladies here are frightened of this, I'm not going to have another one like this tonight. My poor wife is horrified with this. And we went to high school together. That first day, one of the teachers exploded a bottle of hydrogen oxygen, and my wife was in the front seat, and I blew my wife right out of chemistry into botany. She never did. Now I'm going to show you a dust explosion, how a granary explodes. Or how a flower, not only a flower blows up, but how a coal mine explodes. It isn't the coal gas exploding. The gas stirs a coal dust, and the dust explodes. So I'm going to show you a typical dust explosion. Now, if I take this candle and burn it burns very slowly. What could I burn that candle? I'm going to make it burn faster until this explosion. What could I burn that in to make it burn 5 times faster? Pure oxygen. But another way to do it is to live it up and burn your candle at both ends. Both ends, it's going to burn up in half the time, isn't it? Young people, if you burn your candle at both ends, you'll only live half as long. But it's more than twice the fun. Now, suppose we take that, and suppose we have 1,000 candles. Have here 1,000. Do you want to turn all the lights on? Now, that would be nice. Now, I have 1,000 candles here. I'm going to say 1, 2, 3 now, and it doesn't make a boom. Don't be afraid of that. But it will show you what a dust explosion is like. 1, 2. All right, get the lights out now. Now, I'm going to do another one. You were to pop in the boom. Okay, we'll put the top on here. This isn't any challenge at all. Princeton is 65 feet high, and I have more holes in the ceiling. Down there, I'm putting a very little bit of this powder, less than a tenth of a teaspoonful. And in there, there's I'm going to bring it out so you can see it. There's a spark, so to speak. You know, if you're a chemist and you make a spark in a fireman, you come out through the roof instead of the door. So we put that there like that, and this is here. In fact, I'll show you. Hey, you want to come on up here? You're going to do this. Right up here. Yeah. And when I say 1, 2, 3, you're going to squeeze it. See? Not yet. 1, 2, 3. There we go. Thank you very much. But now we're going to put the top on there. If it comes out and it's toward you, duck so it hits him when you do that. Everything is the same. It won't go too high. It won't go too high actually. But I'll see if I can get up near the ceiling. Everything is the same, and it shows. And doesn't matter how much stuff I put in there, it's how tightly I put it in. And I'll try to put it in so to go up near there without not hitting. Let's see. That ought to go just about to it. 1, 2. Of that. If I put it just a little bit further, it's going 30 feet high. But I always try to see how close I can come without any. Well, now, that's a chemical reaction. Now we come to the nuclear reaction. That was where a neutron hit uranium. What they did, they tried to smash atoms, you know. They had a big atom. They tried to smash it. They had their own kind of guns. They tried. And then finally they found what they wanted to do was take a uranium atom, and they took a uranium atom and smashed it with a neutron, then they could get the fission reaction. You know all this, so I'm going over very quickly. And what they did is if you have this big uranium atom, you see how they like that, you see, and then you shoot a neutron out. May I have that neutron, please? The uranium went into 2 pieces. Iron, cobalt, nickel, it was transmutation. And the interesting, never mind, we'll get it later. And the interesting thing is when the neutron hit that, you hit the jackpot. You got 3 neutrons off for the one that went in. Now this is very important, as we'll see. The fact that 1 neutron gave you 3. We wouldn't have the atom bomb, the nuclear reactor, anything if it weren't for that. But you do see it was like transmutation. The uranium 2 other elements. It's like taking this U.S. water and changing it into French wine, you see. Or taking the French wine and changing it into Russian vodka, you see. Or Russian vodka and changing it into Holland milk, you see. Or Holland milk and changing it into Florida orange juice, you see. Or Florida orange juice and changing it into Baton Rouge. Transmutation, my friend. How are you going to get ahead? How are you going to be ready to make discoveries? 3 things. Be expert, be human, and have self-confidence. Let's take each of those. Be expert, sure, you're going to take chemistry if you're going to be a chemist. But far more important, take all the mathematics you possibly can. You put in work and say, I'm going to biology, I don't need it. You know, the biochemistry is the computer puts in more than any other department. Take all the mathematics you can. Take plenty of English so you can express your discoveries and convince people you know what you've discovered. Too many chemical engineers particularly can't write a report for the life of them. They just don't know how to express themselves. Terribly important to learn how to express yourself properly. Secondly, be human. The 2 greatest scientists in our century were Einstein and somebody greater than Einstein. And I'm quoting now about half a dozen Nobel Prizes. We were sitting around one night and discussing, was there anybody like Leonardo da Vinci and Galileo? Niels Bohr was there at the crowd. And they said, Niels would say you're 6th class, 5th class. Heisenberg, Dirac, Schrödinger, Professor Wiener, who's on the campus here. All these people were around, about 8 of them that night. And Alyea was 28th class. And I kept my mouth shut and listened to what they were saying. And they said, we think there's nobody 4th class, nobody 3rd class, nobody 2nd class. Einstein 1.5 class. Not quite. that equal of somebody. I bet you only 15 people who know this man. Max Planck. How many have heard of that? The other thing about the human side is Max Planck in 1901 had the Planck constant, which is the basis of all of modern basis of all modern physics. And 4 years later, all of Bohr's orbits, electronic orbits, are based on the Planck constant. 4 years later, Einstein took the Planck constant, applied it to 5 fields. Only one of the two would have won the Nobel Prize. And one did. But if he hadn't had a Planck to stand on, he wouldn't have gotten anywhere. But the homely thing is that the year I was in Berlin, every Saturday, Einstein appeared at Planck's house with his wife under one arm and his violin in another. He and Planck sat down and played from 3 in the afternoon to 10 at night with an hour out for dinner. They didn't find that music in truth that made them dream. And so I beg of you, yes, be an expert, be human. Do artistic things, painting, dancing, drama, music. These things are the things that will make you a great scientist. And finally, self-confidence. And in that story, this is the end of the story before I sing. That story is how I first met Einstein. I was working with Fritz Haber in Berlin, and he brought Einstein in to see my very elaborate apparatus. Now, it was a very long tube, and it went into a couple of lenses, and you gaze, and you twist them until the lights are equal intensity. And then you could read how much oxygen was in this interferometer. And to my horror, Einstein comes, and the wrong end was just a pipe. And he's looking like this and looking like this. Now, what would most of us have done? We would have been ashamed to show our ignorance, wouldn't we? And walked away and said nothing. But not Einstein. He looks and he says, God, I can't see anything. He said, heck about it. I'm doing this side here. Or this side here, Professor. Got down and showed her. He said, wunderbar. There you see, I learned that day something terribly important. Never be ashamed to show your ignorance once, rather than remain ignorant all your life. He wasn't afraid, and you don't either. And so, I say, as you gain self-confidence, young people, don't be afraid of great people. When you have an interview with them, they're human at that moment. Treat them like human beings. They have sex drives, they cry, they laugh, they put their fans one leg on a time, they go to the bathroom just like you. They are human beings, and if you treat them that way, you'll get understanding them much better. And choose what you're really excited about in life. Be sure you choose what you're very excited about in life. I'm down in the lab 6:30 in the morning. I'm still working around 10 o'clock. I'm still playing. And you can do that too. If you choose the right thing, not because it'll give you a lot of money, but because you are so excited about what you chose for life, and keep on doing it. Well, I'm going to end by singing a song now. This is a song about Yale, Princeton, and Harvard. And those are our arch enemies, you see. And the song goes like this. Now, first I'll put something down here and tell you about it. It goes, oh, Yale has always favored the violets, dark blue, that's Yale, see. And the many sons of Harvard to the crimson rose are true. This is Harvard, you see. And I'll get this ready now. When I come to the violet, you're going to see something violet here. Some iodine is going to look violet here. And I can't put that here. Put this down here. I won't do it yet, but I've got some right here. Some of this concentrated sulfuric acid here. Squirt the water on that, you're going to see it, and see all these things. Oh, Yale has always favored the violet, dark blue, and the many sons of Harvard to the crimson. There's the sons of Harvard to the crimson rose of true. We'll all up. Now comes Princeton, and just like you have a tiger here, Princeton is the animal, the tiger, and it's orange and black. We'll all the little slender, nor honor shall we lack, while the tiger stands defender of the orange and the black. So you can see all these things happen now. And I tell you, I did this reunion down at Princeton, all the old grads come back. And one year, David First and my sister Kim talking, he says, something very touching happened. As you began to sing, oh, Yale has, he said, an old white-haired gentleman in the back row, tears began rolling down his cheeks. He said, oh, it was a touching thing. I went back to him and said, a good man, what year at Princeton were you? Oh, he said, I'm not a Princeton man, I'm a musician. This will be the end of it. Now, so to get this will be the violet from the eye. society. Oh, Yale has always favored the party. Oh, let's dark blue. True. You know, that's a little peak, but that's what Harvard usually is, peak. Nor under shall they lie, while the tiger stands defender of the